Howdy! Welcome to TMG's Math Emporium. I'm TMG, and today we're going to be doing some integrating factor with respect to differential equations. Now, one of my friends from my current residence hall asked me why this differential equation, y prime equals x plus y, has an e to the x term in it. I know that's a bit of a spoiler, but I will show you why. Now, in Calc 2, you most likely learned a method known as separable differential equations, where you can separate it into factors involving y and x. However, you can't really do that here, since x plus y would make that pretty much impossible. However, we can use another method called integrating factor. Here's how it's done. So, first we will move all the y terms into one side, right? So if we subtract y from both sides, we get y prime minus y equals x. And now we have to calculate our integrating factor. It is denoted as a mu of x, which equals e to the negative integral of the coefficient in front of y, or not neg. X. For clarification, it's not always negative. It's just the coefficient in front of your y. So it would be e to the negative x. So you would multiply it by both sides. So here you would get e to the negative x times y prime minus e to the negative x times y equals x times e to the negative x. Now, what now? So in Calc 1, you learned that the product rule is d dx of f of x times g of x equals f prime of x g of x plus g prime of x f of x. Now, you may notice that one of that our f of x could be e to the negative x, and our g of x could be y. So we can substitute those in for that function. So we get d dx e to the negative x times y is equal to x e to the negative x. What now? So now we can take the derivative, or the integral, the antiderivative, with respect to with dx. So this dx, this dx. So this side is fairly easy since the dx's cancel out, so we just get y times e to the negative x. However, this one will require a bit of integrating by parts. Now, the common way is using a formula, but I have a different method that makes it a lot easier for me. It's the method that I was taught in school and was also used in the movie Stand and Deliver, which is a personal favorite of mine. So you pick your u and you pick your dv. So your u would usually be a value that, if you take multiple derivatives of it, it would go down to 0. So in this instance, it would be x, and your dv would be what's left over, so e to the negative x. So you differentiate u and you integrate dv. So you go d dx of x is 1, and derivative of that is 0. And the integral of e to the negative x with respect to x is negative e to the negative x. Second integral, well, I'm not talking about double integrals, that's a Calc 3 topic. But the second integral of e, if you integrate e to negative x twice with respect to x, you get e to the negative x. And then to get your general solution, you multiply these two together and add them, and then you multiply these two together and subtract, and not add and subtract. You multiply these two, and you two, and then multiply by positive 1 for this one, negative 1. I apologize for the confusion. And so you would get x times e to negative x, negative x times e to negative x, and then minus e to negative x plus c. You can't forget the plus c. Now, we still don't have the equation in terms of y, so we can just multiply everything by e to the x. And a lot of it just cancels out. So this cancels. These will cancel. These will cancel. But this will not. So y of x will equal negative x minus 1 plus c e to the x. And if you want to, and to prove that we're right, we can plug in the equation back into the original differential equation. So y prime of x would be negative 1 plus c e to the x. So it's plugging into this. We got y prime, which is this, and then we take x plus negative x minus 1 plus c e to the x. And then and we can just get rid of these. Cancel. This is the same as this. So that's how you use integrating factor. For review, basically to solve a first order differential equation using integrating factor, you put all the independent variables and the dependent variables separate, and then you multiply both sides by e to the power of the integral of the coefficient in front of your y, or your independent variable. Now, this is not going to work for every differential equation or first order differential equation, but it will help especially if you have a non-homogeneous equation. And non-homogeneous meaning that the stuff involving y's, summing those does not equal 0. Alright, thank you for watching, and I will see you next time. TMG out.